Hello, welcome to Easy A Assistance. Today I'll be discussing significant figures and scientific notation. So let's get started, shall we? I'll begin with just the basic significant figures. So they're there for when there's an uncertainty of a measurement. So that means something you measure on, like, let's say a graduated cylinder. So this isn't just some calculation. Like if you're like, what's 100 times 5? There's no significant figures there. Those are just real numbers. So it's 500. You're not going to like adjust the answer to be significant figures. So if you see at the bottom, remember, only for uncertain, not conversion factors, like in percent error, which Lerone will be doing a video about, where you multiply by 100 at the end. So you're not going to just do one significant figure for the 100 at the end. It just wouldn't work. So note, these are only for when you multiply with a measurement. Okay, so let's get started. There are two different types of significant figures, like ways to find one. So the first one is when a decimal point is present. So a useful way to memorize this that was taught in Mr. Engler's class was present, which starts with a P, means you start from the Pacific side. So Pacific is West Coast, that's the left, so you start from left to right, right? So left to right. So let's say the number is 57.3. That has a decimal. So that's three significant figures, 5, 7, 3. Then remember, with counting significant figures, it always starts with the first non-zero digit. So for a number like 0.003, that's going to have only one significant figure because the zeros don't count. Those 3 zeros, they don't count. Only the 3 count. So there's only one significant figure. Then the other side is with no decimal place present. So a good way to memorize this is the decimal is absent, so you count from the Atlantic side, which is East Coast. That's where I am. We're currently getting hit by a blizzard, so yay. And you start from the right to left, right, just like the East Coast. So just like the other one, you go from the first non-zero digit. So an example would be like, let's say 2,000. There's only one significant figure, the 2. Or like, let's say 543. There are 3, the 5, 4, and the 3. So here's a couple examples. 5.3056. How many significant figures is that? You solve it. Okay, are you ready? There are 1, 2, 3, 4, 5. There are 5 significant figures. Here's why. There's a decimal point present, so you count from the left side. And the first number is a non-zero, so all numbers are going to be counted. All 5 numbers. So 53056. 5 significant figures. Second one. No decimal points. 10,500. Let's go from the first non-zero digit. 00 doesn't count. 5. So 501. Those 3 numbers right there count. So there are 3 significant figures. And then we have this one. Decimal present. So we're going to start from the left. 0001. Let's start with here. 1020. So that's 4. Even if there's a 0 at the end, you can include that. So there are 4 significant figures, the 1020. So to recap, there's 5 here, 3 here, and 4 here. So now that we finished with the basics of significant figures, I'm now going to cover what you do when multiplying with them and what you do when adding or multiplying and dividing, and what you do when you add and subtract, because there's different ways. And then I'll also cover a little bit of scientific notation. So you're probably watching this video for help with your science class, or maybe you just love significant figures, and then I don't know why you love them, but good for you. So let's continue, shall we? So for the second part of this video, I'll be discussing some of the more complex aspects of significant figures. So there's 2 different types of ways to use them in a problem. There's the multiplication and division, which what you do to get the answer for like how many figs you use in the answer, you do it by the least amount of significant figures in the two original numbers. So let's say we have 2.5 times 120. So 2.5 has how many? 2 significant figures. 2 and 5. 120 has how many? 2 significant figures. 0 doesn't count, so 2 and 1. So the answer is going to have 2 significant figures. What would you know? So the answer is 300, right? but that only has 1, only the 3, because the zeros don't count. So how do you work around that? You use scientific notation. So scientific notation allows you to like just multiply something times 10 to the something, and it's kind of used in this aspect to work around significant figures like issues. So to get the two significant figures, you want a decimal point there, so it's 3.0, which is two significant figures because you're starting from the left. 3.0 times 10 squared. So 10 squared, that's 100. 100 times 3, 300. So there you go. 3.0 times 10 squared is the answer. Then we have a division problem. 10 divided by 2.5. So 10 has one significant figure, the 1. 2.5 has 2. So the answer is going to have one significant figure. Luckily, it works out cleanly. There's no rounding necessary. And 2.5 goes into 10 4 times, so that's your answer. Now we move on to the second part, which is subtraction and addition. So here the answer has the significant figure number of the original data with the least amount of decimal places. So for multiplication and division, I'm going to repeat this one more time, it's the least amount of significant figures in the original data, but for subtraction and addition, it's the least amount of decimal places. So we have an example with subtraction right here. So remember, there are no fractions, so it's always going to be decimal places. So here's an example. We have 205 minus 3.6. So 205, 0 decimal places. 3.6, 1. So the answer is going to have 0. So that's like, wait a second. That equals 201.4. How are you going to work around that? What you do? You gotta round. You gotta just say goodbye to that 0.4. I know it's sad, but you gotta say goodbye to it. So you get for your answer 201, which has 0 decimal places. Now we got some addition right here. So 0.6549, that's 4 decimal places, 1, 2, 3, 4, plus 0.36, which has 2, 1, 2, equals 1.01. So the actual answer is a lot longer, but it has to have 2, so you have to round and stuff, and you get 1.01. You have to cut it short. I think the actual one was like 1.0149 or something, so the 4 doesn't move up the 1, so it stays the same, just 1.01. So I'm going to do one scientific notation problem for you at the end. So write 2,650 with 6 significant figures. So 2,650 has how many? 3 significant figures, right? 0 doesn't count, so it's 5, 6, and 2. So we're going to use scientific notation, our new best friend. So I'll give you a second to get the answer. Now I'm going to show you. 2.65000 times 10 to the third, 10 cubed. So yeah, I know it's a little like excessive and a little extra, but that's what you gotta do. You gotta have decimal places, because without a decimal place, it's going to start from the right. So if there's a 0 there, it has to wait for the first non-zero number. But with a decimal place, it can just start with the 2. So you get 2, 6, 5, 0, 0, 0. So that's 6. So that's how you do it. So scientific notation is really your best friend, and significant figures are your worst enemy. So that's what you need to know about significant figures and scientific notation from Mr. Engler's and probably all chemistry classes, honestly. This is a very just crucial aspect of chemistry that'll take you through the rest of the year, so it's really just suitable for Intro to Chem. So thank you for watching. I hope you enjoyed the video. Try to keep it fun here, even though it's chemistry. So I hope you come back to Easy A Assistance sometime soon. See you guys later. It's Shane. Bye.